Assalamu alaikum students, this is Farwa Batool, your O-level computer science instructor, and welcome to another video. In my previous video, we have seen validation and verification checks along with their types, and now in this video, we are going to talk about another important topic, that is test data. So let me give you a background. We know that whenever there is a problem in programming, the first thing we do is to propose a solution for it. Propose a solution for your problem. And once we propose the solution, we start writing algorithm or sometimes the flowchart for the solution that we proposed. Okay. Once the algorithm or the flowchart is being written or designed, the next stage is to test your algorithm or flowchart. And why we need testing? Testing is important in order to see that whether the algorithm or the flowchart that you have written is working the way it is expected or there are some errors. So, in order to see your algorithm, that how it is going to work, you are going to use some sets of test data. Set of test data. Let me give you an example of it. For example, I have written an algorithm in which the user has to input 5 integer values, and your algorithm is going to tell you that what is the maximum integer that the user has input out of these 5. So, in order to test this algorithm, once you write it, to test it, you need 5 integers as a test data that you will input in your algorithm, and you will see if the algorithm is able to find the maximum integer or not, so that you will know that your algorithm is working the way it is expected or not. Now let's take the test data for this example. Let's take a normal data. The normal data is the one that is expected by the user to enter. Let's take 7, 12, 19, 3, minus 2. Or, okay, so these are all the integer values. Now, one thing is that we have the expected result for this input. And the expected result says that all of these maximum values, all of these integers that are given as a test data to this algorithm, the expected result of the algorithm after finding out the maximum integer would be 19. So, when we are going to work through the algorithm, if the result that we see on the screen is 19, then you can say that yes, the algorithm is working the way it is expected. So in this way, we can use different sets of test data to test the algorithm that we have defined. Now, quickly moving towards the type of test data that we will set for any algorithm to check it's working. Before that, let me just write down the definition of test data for you. Okay, so by definition, the test data is all the items of data required to work through a solution or an algorithm, we say, and it determines whether a solution is working as it should. So it means that test data helps you to test your algorithm, to find out any error in it, and to check that whether the algorithm is working the way it should or not. So this is the definition. Now I am quickly moving towards the different type of test data that we can use for any algorithm to test it. Okay, so the first type of test data is the normal data. Normal data is a type of test data that is typical or expected that the user can enter into your algorithm, and it will be accepted by the system and algorithm. Now, let me give you an example of the normal data. For this, let's assume an algorithm that is taking student age as an input. Okay, there are two validations for the input data. The user must input an age that is between 9 to 14. The age cannot be less than 9 and cannot be greater than 14. This is your range check. And the second thing is your type check. The user must always input integer value as age of the student. So this is the type check. These two validations are applied on the input data. So keep in mind, now normal data is going to be the data that will be accepted by your algorithm, and the algorithm is going to work as expected. Now, the normal data will, for this particular algorithm, the normal data should be the data that validates both range check and the type check, or that satisfy all those values of input data that satisfy your validation are going to be your normal data. And keep in mind that the data must be an integer value and it must be between 9 and 14. So the normal data can be 9, 10, 11, 12, 13, 14. All of these values, since the values are satisfying the range check and the type check for your given algorithm, that's why all of these values will be considered as the normal data, because these values will be accepted by the system. Now, quickly moving towards the second type of test data. Here we go. The second type is the extreme data. By definition, extreme data is test data at the upper or lower limit of expectations that should be accepted by the system. Very easy. All the expected values or the normal data, test data, is available here. 9, 10, 11, 12, 13, 14. We will see the lower value here and the upper value. The lower value that will be accepted by the system is 9, and the upper limit of the test data that is accepted by the system is 14. So this is going to be your extreme data for this example. 9, the lower limit, 14, the upper limit that will be accepted by the system for this given example. So this is your second type of data, the extreme data, in which you are going to take the upper limit and the lower limit of your test data, or the normal data in other words. Now let me tell you the third type of test data that we can take as a test data to check our algorithm. Here we go. This is the boundary data. I want to explain you this in detail. A boundary data is basically the pair of values at each end of the range. Now, in this example, we have the range that starts from 9 and goes till 14. So, at both the ends, we are going to have a pair of data. So, the boundary data for this range is going to be two pairs. Now, let's see that what would be the values of these two pairs. See over here. Let's suppose this is my pair number 1 and this is going to be the pair number 2. Let's find out that what would be the values in the pair. For the first value of the pair, look at this. The data at the upper or lower limits of expectations that should be accepted by your system. So it is just the same as the expected data. The upper value or the lower value that is accepted by the system. So the upper value we know is 14 and the lower value that will be accepted is 9. So we got the first value of the two pairs. Now quickly see this one for the second value of our pairs. The immediate values before or beyond the limits of expectation that should be rejected. It is very important that the immediate values that will be rejected by the system. Now, if the first value, the lower limit value, the lower limit of my normal data was 9. So the immediate values will be, let's take 8 here and let's take 9 and then 10. The immediate values for the integer 9 would be 8 and 10. Now we have to see that which of these values needs to be accepted as pair. Now look at this. The definition says that the second value in the pair must be rejected by the system. The first value would be accepted by the system and the second value would be rejected. The pair must be made in such a way that one value needs to be accepted and the other must be rejected. So if I take 10 as an immediate value for the integer 9, the lower limit, then I know that 10 will be accepted by the system. And I cannot have a pair in which both the values will be accepted. However, the immediate value 8 is going to be rejected by the system. Why? Because this 8 is out of range. The range starts from 9 and goes till 14. So 8 is an integer value, but it will be rejected by the system since it invalidates the range check. So you have to take the pair in such a way that one value needs to be rejected and the other accepted. So in this case, we are going to avoid 10 and we will accept 8 as an immediate value for my lower limit 9. 9 is accepted and 8 is rejected. This is going to be my first pair. Now in the second one, the immediate values of 14 are 13, that is before 14, and 15, that this value is after 14. Both are integer values. Now we have to see that which of these values will be rejected by the system. Since the value 14 is your upper limit and it will be accepted by the system. Now, if I take 13 with 14 as a pair, then I know that 13 is also accepted by my system. Why? Because it is within the range. And I cannot have a pair in which both the values will be accepted. However, if I see 15, then 15 is out of your range. So this value is going to be rejected for this example of algorithm. So it is better to take 14 and 15 as a pair for the boundary data, because in the boundary data you have to take pairs at both ends in such a way that one value would be accepted by the system and the other value must be rejected by the system. So this is going to be your boundary data, the two pairs at each end of your range. Now, quickly moving towards the fourth type of test data. Okay, so here we go. Now the fourth one is abnormal or erroneous data. The abnormal data is the one that is just opposite to your normal data. And remember that it will always be rejected by the system or algorithm, or the validation check will always be rejected, or will always be unfulfilled by the data. Now let's see an example. The test data, for example, normal data was, let's take normal data first, 9, 10, 11, 12, 13, and 14. All these ages will be accepted by the system. Now, if I take any value before 9, that can be 8, that can be 5, that can be 3, that can be even negative value, -1, -5, and so on. And all values that is after 14, 15, or 20, or even 100, and so on, that are out of the range will be rejected by the system, and that's why they are abnormal data. They will all be considered as abnormal test data. And other than that, if these are all the integer values, and remember that the values that are not integer will also be rejected by the system. Why? Because the second validation is, this is the range check, and the second validation is your type check, that the values must be integer. So all those values that are invalidating the type check. For example, an input a string like 10. Instead of writing an integer 10, I'm writing a string 10. So it will be rejected by your system. And all the decimal values, 13.6. Even if it is within the range, but since it is invalidating the type check, that's why it will be rejected by your system. So all these values will also be considered as abnormal or erroneous data. So these are all the four different type of test data that I have explained you in this video. Now in the next video, I am going to solve the problem of your book so that this topic is going to be clear to you. Thank you so much. Stay tuned, stay connected, and do not forget to subscribe the channel. Bye bye.